Hello, everybody. Thanks for joining me again today. Let's switch to the code view. Let's dive right into drakon again. Today, I'm planning to work on changing the types yet again a little bit because I promised the last time that I would do some homework with them. And here's what I came up with off camera. So I hope you have your drink of choice ready. And let's talk types today. So previously I used types like drakon diagram. That used to be a list of diagram blocks. But the problem with this is it doesn't really reflect what drakon sort of enforces. Well, enforces is too strong of a word. It doesn't really follow drakon rules because this list of diagram blocks really doesn't tell us much about the beauty of drakon like block arrangement. A drakon block can be one of these three things. Well, I've already started doing some refactoring, but it can either be a terminator or it can be a skewer block. But this type doesn't tell us anything about the arrangement. For example, using this type is perfectly acceptable to have a list consisting only of terminators. That's not correct. I mean, you could have a start and end terminator, but if you arranged 10 start terminators alongside each other, that would still be considered correct with this type. So I wasn't particularly happy with this. So the type I proposed is this. Let's hide this. Drakon, I should have written drakon diagram. So the drakon diagram is a product type that maybe let's do this. I forgot. Well, I treated this name as a data constructor, while in fact I wanted it to be a type parameter. So, our value. So our type constructor drakon diagram will have one data constructor drakon diagram, the same name. And the order of blocks is now much clearer, I think. First goes a start terminator, which is one of these things. So a start terminator is a sum type, and we can have 4 possible start terminators, either a title, cyclic start, title with parameters, or cyclic start with parameters. This is 100% in accordance with the white paper. There are no more start terminators. And then we have a list of skewer blocks, and now we can afford a little bit more liberty. These skewer blocks can, in this case, be arranged however we want. And I'm saying this now. I'm not probably seeing any edge cases, but it makes sense to me now. You can have an action and a question, and then another action, or the order can be reversed. So I think this works for me for now. And the last type parameter of a drakon diagram is a finish terminator. And according to the white paper, we only have one finish terminator, but I still wrapped the end. Well, I still treated the end as a data constructor for this type. So I think this will work a little bit better. Now, the beginning of this session I would like to devote to adapting this type into our application. So now we can remove this. And a drakon diagram we'll have to rearrange a little bit. So the first thing is the start terminator. We can delete the blocks. So, sorry. I hope this is correct. And the finish terminator goes last. So here we can just say title. I think that should work. And here we can just say end. I'm not sure the formatting is perfect, but we shall find out. Now this will have to change a little bit now. These are skewer blocks. Let's keep in mind that I'm not rendering the start terminator and finish terminator yet. We just have types for them, or we only just have the types for them. We don't have the render type class implementation yet. Let's see where this type is. Okay, so now we can remove this type. We don't need it anymore. Now question. I don't believe a question can be present on its own, but let's leave it for now. This we can remove. So this can just be an action. This can just be a fork. Okay, so it builds finally, but we have no use for finish terminator and start terminator yet. So let's use that time to fix this annoying warning. 175. But I do believe this is also needed. Okay, so now a smart thing to do would be to provide implementations of these terminators. And let's see. Sorry for skipping like that. And the longer I think about a fork, the more I'm convinced that the question maybe shouldn't be exposed. And also that it shouldn't be a product type. Sorry, it shouldn't be a record. Because a record doesn't really tell us much about the structure of a fork. Meaning that it shouldn't really be allowed to have this question as a field, because what else would a fork have? It only needs a question. It cannot even be a skewer block. So I think I'll just do two things. I'll remove the question again, and it will be an implicit member of a fork. And it also cannot be a skewer block. It gives too much freedom. If we wanted to, we could construct a fork which has an action that is pretending to be a question, if that makes sense, because an action is a skewer block. So you know what? Let's do this. Let's provide an instance of a start terminator. Oh, we already have an instance of render for start terminator. So 249. We can do this. Render start terminator here. If I build it now, it should build, but it shouldn't be correct. Maybe this. Do we need this in brackets as well? Yes. That's a good advice. Oh, and we don't need brackets around this. That's good. Now, the reason why it wouldn't render correctly is because the starting Y position of origins of these skewer blocks starts with just a plain Y, and it shouldn't, because first goes the terminator, as the start terminator. So we need to say Y plus. Oh, this is good. Good suggestion. I hope it works. Oh, we don't even need the brackets, I think. Let's see. And now let's add now not origin, but And that should be minus because we're going down. And here we just say same x. I think this should be fine. I will need to format this, but let's do it in a little while. One more. One too many. Oh, sorry. This is already first. Okay, so this was not needed. That's good. And I also started this document where I go through all the white paper drakon rules, and I start noting down all the terms that I find there, new and old, and I'll try to put this together into like a mind map, so it's easier to digest. For some reason, these rules are very hard for me to fully grasp. The white paper requires you to jump from the rules, which are at the end of the white paper, all the way to figures that are at the beginning. It's easy to lose focus. So I should have it ready soon. Now, let's format this file. That's a branch. And this is the code that I've just added. And see, I'm already seeing the benefits of representing the drakon diagram with the new type. See, the type already enforces a certain way of thinking about what a diagram is and how to visualize it, even without seeing the the rendered SVG. If you want to render the drakon diagram, you first render the start terminator, then you map end your skewer blocks that are rendered, and finally you append the finished terminator. Now let's try to run it and let's see if visually it still makes sense. I think it does. I think I shaved off some elements. 1, 2, 3, 4, 5, 6, 7, 8. We are having a little bit of a mix up with calculations, but we can correct this now. Width is correct. Because the skewer blocks will never be of lower width than the start or end terminator. Or maybe. I can't remember what the width is going to be of the special type of start terminators. So just to have a clear conscience, let's do this is a map of numbers, so we can't do that. Okay. So that's width, and height is going to be very similar. It's a sum. And just to respect the type that we've just added, let's also preserve the order of operations. And now, if we run it, the height should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I can either preserve the order or preserve the clarity. Let's preserve the order. Well, the clarity, the compact sort of syntax. it's okay if we're sacrificing some performance. It just looks nice. So with the width should still be 3 and the height should be 10. Great. All right, so we have everything implemented now. Let's check the time quickly. So okay, so I feel this part of the session is finished. And the next part of the session, I would like to start writing a sort of very concise, quick and dirty parser for various inputs, just to test the diagram with different inputs. I thought about doing either that or the connections. Maybe I should do the connections first. You know what, let me take a quick break and then I'll decide. I'll be back in a second. Okay, I'm back. So I think I'll go ahead with the parser, simply because this is connections I'll have to do either way, sooner or later. And this is a part of the effective Haskell book that I'm currently going through, and I'm just very curious to test it out. I used to play with parsers following the Programming in Haskell book by Graham Hutton, and this is where the difficulties began for me, as monadic parsing is not for the weak, and I fear I was categorized as the weak. I still went through it, but it wasn't an enjoyable experience for me. I rewrote it like 2 or 3 times, the exercises from the book, but I still wasn't happy. So I'm very curious to try the parser that Rebecca Skinner proposes. It's for a calculator exercise, but it's reasonably similar to this. So let's spend a little bit of time on this and let's see what happens. So first of all, writing input like this can get a little bit, as I found in the book, obnoxious. That's the word that was used, and I do agree. Providing input like this, if I was to provide the input in the input arguments of the executable, would be obnoxious. But let's try to simplify this a bit. So, you know what, before we start playing with the parsing, let's simplify the fork type, because I just don't feel it should be a record type. The question should just not be an input. And in that case, fork branch. I think this makes it much easier. I'll have to do some refactoring, but I think it will be worth it. So here we can just cut this off or cut it out. Same here. And the whole input has gotten so much easier to read. Yeah, we also don't need this. Yes, that was a good decision, I feel. Keep in mind, we still don't have an implementation for the textual content of a fork or an action, but we'll get there. Fork block. So in that case, these are two different types. So we can simplify and just go like this. How about that? Now we'll have to move the implementation of fork here. So this is our fork. And now we can remove this. And we're actually shaving off many lines of code. So here we can go directly fork. And same with this piece. Mm-hmm. And we have shaved off a number of lines. Okay. Does it mean it will work the same way here? It should. Okay. Apparently these are not needed. That's good. No hints. Okay, so let's visit this thing. It also doesn't look entirely correct, but let's leave it for now. Okay. Final test if it still renders and runs. Yep. So today was more refactoring than adding like visual components or value. Well, we have added value, but you can't really see it in the rendering. And I think we'll draw the line here, and I'll start on the parser the next time, or maybe maybe at least let's define a hook for parsing so that I know where to start during the next session. Okay. So, to provide a function that will serve as a hook, we would have to do maybe, I think so. Or the book here says use the either type. Okay. So here, so this would be a string. And the book suggests that we use the function words to break up x into tokens. And now, oh, so the function will have to provide That's an interesting suggestion. So a parser, as I still remember from Gray and Hutton's book, returns the parsed result and the rest of the tokens. And so does this book say. So let's not define the parse here in line, the parse prime, but instead here, so that I have a good insight into the types that it expects. So you have tokens, and here we have a list of tuples. Or an either. A list of tuples or string. So it's either an unparsable token or a list of pairs, drakon diagram and a pair of drakon diagram and a list of tokens. For now, let's just go with that's perfectly fair. So this happens when we get a diagram and nothing else. We just return a diagram. And here, if we have a diagram and more tokens, this, let's consider an error. So here, my AI companion tells me I should use show more tokens, but instead I can just do onwards, and that will glue those tokens back into just one string. Oh, this we don't need. And let's park this. Old function main. Or maybe let's keep it. Or we can just do okay. Let's start with something simple. I'm not sure our diagram implements show. Let's make this an instance of show for a diagram. string number 1, string number 2. Let's ignore those tokens for now. Success, not implemented. But it's fine. Right. I think we're slowly running out of time. Yeah, that was a pretty long session today. Yeah, during next session, I'll probably be continuing with a simple parser. And after that is done, I feel that we could move on to connections and maybe to connecting everything that we've learned this week back to the sort of old skeleton of the project. I feel we're making very good progress this week, and I'm really enjoying myself writing the code and simplifying the layout engine. That will get simplified. The representation of types will get simplified. So we probably won't be relying on JSON to read the input from, but we'll see. Still very excited about the project, still very happy to be working on it, and it is very rewarding. So anyway, I wish everybody a fantastic weekend ahead, and I hope you have a great day. Take care, and I'll see you next time. Bye.